numbers are made up of different place values. So for example, if we have this yellow block here, this represents the ones. So this single yellow block is just a 1. As we move along the place values, it gets 10 times bigger each time. So the next place value is going to be the 10s. So this 10 is made up of 10 ones. The next place value is going to be 10 times bigger than the 10. So that is the hundreds. So this 100 here is made up of 10 tens and 100 ones. Okay. The next place value is the thousands, which is 10 times bigger than the 100. So this 1000 here is made up of 10 100s, 100 tens, and it's made up of 1000 ones. So this is the thousands, hundreds, tens, and ones. The next place value is going to be made up of 10 1000s, because it gets 10 times bigger each time, which would be the 10,000s. And this just keeps going on. So if we just look at the first 4, we can see this number here is 1111. So the numbers are telling us how much we have for each place value. So we have 1, 1, 110, 100, and 1000. So now if we start adding blocks to this, we can change the number around. So if we had, say, another yellow block, that now becomes a 2. So we have 1112. If we add another 10, so just another 10, that now becomes 1122. If we add, say, another 200s, that's another 200s, this number now changes to 1322. If we add another 1000, that becomes 2322. If we say add another 3 ones to that, that now becomes a 5. So we now have 2325. If we say add another 3 tens here, so that's another 3 tens, that now becomes 5 as well. And we add another 1 there, so that becomes a 6. Okay, so that is 2356. So each number is just telling us how much we have for each place value. So if we was to add, say, another 4 ones to this, so if we add another 4 ones, so that's 10 in total, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can exchange these 10 ones for another 10. So if we can put back here, that 6 goes there, and because we exchanged it, we can then get rid of these. So now we have 0 ones. So this number is now 2360. So this is telling us we have 0 ones. If we was to add, say, another 4 tens, so let's add another 4 tens. So that's 2 there. So that is 10 tens. So if we count that, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 tens. We can exchange that for 100, and then that goes into the hundreds place. Okay, so that becomes 0, and this becomes 4. Okay, so now we have 2,400. So now it's telling us we have 0 tens. So we have 0 tens and 0 ones. So this number here is 2,400. So next we're going to look at place values with decimals. So in the previous section we said that this yellow block represented a 1. We're now going to say this blue square represents a 1 instead. So we're just making that switch. So previously we said down was a 1. We are now saying this blue square is a 1. So before, when we moved to the left, the place values were getting 10 times bigger. Now we're going to move to the right, where they're getting 10 times smaller. So 10 times smaller than the 1, or the whole, is the 1/10. So this is a 1/10. and this is 10 times smaller than the 1. Okay, so this is the 1/10. If we go 10 times smaller than the 1/10, we get the 100ths. So it's called the 100ths because this is 100 times smaller than the 1. The next one, so 10 times smaller than the 100th, is going to be the 1000ths. So this is called the 1000ths because it is 1000 times smaller than the 1. Okay, so if we just move these up a bit. So now if we start the numbers in, so we have 1, so there's a 1 whole. We now have to put our decimal point. So once you see a decimal point, this means you're no longer dealing with whole numbers. Okay, so this is the whole number here, so that is a 1, and we have these parts of the whole. So this place value here will tell us how many 1/10ths we have. So that is a 1/10, so that is 1 1/10. We have a 100th, and we have a 1000th. Okay, so this number is 1.111. So if we add another, say, 1/10, we now have 2/10. So that now becomes 1.211. So we have 2/10, 1 100th, and 1 1000th. So we can keep changing the number around. So if we say add another 2 1000ths, then that becomes 3 1000ths. So that is 1.213. If we add, say, another 4 100ths, that becomes a 4. So we have 4 100ths. So this is now 1.243. So if we add, say, another 10 1 wholes, so this is made up of 10 ones, so this represents a 10. So if we put a 1 for that, we now have 11.243. So we can see here that 10 100ths, so if we put in 10 100ths in here, so we need another 5, so another 4 then. So put another 4 in there, so that is 10 100ths, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can swap these 100ths for a 1/10. So if we swap it for a 1/10, put that in, and now this becomes a 0. So this is now telling us we have 0 100ths because those 10 100ths, we swapped it for a 1/10, okay? And that now becomes a 3. So the number now becomes 11.303. And that is place value with decimals. We can also use money to represent place value. So you can see here this 0 is the place value for the ones. So if we put a £1 coin, we're saying that is a 1. So previously we said that the yellow block represents a 1, and when we did place value with decimals, we said the large blue square represented a 1. So with money, we're saying the £1 represents a 1. So if we add another pound to that, that changes the place value there to a 2, so telling us that there's 2 £1 coins. So it's £2. We add another one, that's £3, and so on. So if we had 10 £1 coins, that would give us a £10 note. So if we add a £10 note in there, that changes the place value for the tens to a 1, telling us we have one £10 note. If we add another £10 note, it changes it to a 2, add another one, and so on. So that is 4 £10 notes here. So that is £40 on top of £3, so it's £43 in total. So if we had 10 £10 notes, we would get a £100 note. So this doesn't actually exist. Okay, this is just for illustration. So that is a £100 note, so that changes the value for the hundreds to a 1. It's telling us we have one £100 note. If we add another one, changes it to a 2, so that is £243 in total. If we had 10 £100 notes, that would give us a £1,000 note. So again, this doesn't exist. So there's the value there for the thousands place changes to a 1, telling us we have one £1,000 note. If we add another one, it changes it to a 2, and so on. So we have £2,243 here in total. So now if we look at the decimal, so the 10p coin is 1/10 of a pound. So this place value here represents the 1/10. So we have 1/10 of a pound, which is a 10p coin. So that is 2 1/10ths. So that's 20p. And we add another one, that's 30 pence. So we have 3 1/10ths. So if we look at the 100ths place, so we have the penny. So if we just put a penny in there, that is a 100th, because there are 100 pennies in a pound. So the total money here we have £2,243, and we have three £10p coins. That is 30 pence on top of 1 pence, so it's 31 pence. So let's start labeling the place values. So we can see we have this number here, so we have 3,246.487. So let's start labeling the place values. So we can see this 6 here, that 6 represents the ones, so that is the ones. This 4 here represents the tens, so we put a small t there, just saves us from having to write out every time. So we put a small t there for the tens, so this place value represents the tens. This place value here is the hundreds, so we put a capital H there to tell us that is the hundreds. This value here is the thousands, so that is the thousands, so we put a capital T for that, and that is just helping us differentiate between the tens. So the tens has a lowercase t and the thousands has an uppercase T, so that's just to tell the difference. So for the 4 there, that is going to be the 1/10ths, so lowercase t there, so OT for 1/10ths. We have an 8 there for the 100ths, so the 100ths. The 7 there for the 1,000ths, again using uppercase T there for the thousandths, and we have lowercase here for the 1/10ths. So let's look at the other place values. So if we say add a 5 onto here, so each time it gets 10 times bigger. So if we move into the left, it gets 10 times bigger. So 10 ones makes up a 10, 10 tens makes up 100, 10 hundreds makes up 1,000, and 10 thousands makes up the 10,000s. So this is the 10,000s here. If we go up to another number, let's say we have 8 here. So this value would represent the 100,000s. So that's the 100,000s, because we have 10,000s here. So 10 times bigger than that is the 100,000s. So let's put another number. So let's say we have 2. So if we have 10 100,000s, that would be for the millions. So this is the millions. So let's write the value for each one. So that 6 there just represents a 6. The 4 there, that represents 40, because we have 4 tens. 2 100ths, that represents 200. 3 1,000ths, that is 3,000. 5 10,000s, that is going to be 50,000, because 5 10,000s is 50,000. The 8 there, that is 8 100,000s, so that is 800,000. That's for this value here. The 2 there, that is for the millions, so we have 2 million. So if we write that here, so we have 2 million. So that is the value for the 2 there, because it's in the millions place. So now if we look at the decimals, so we have, say, 2 there, that is going to be the value for the 1/10,000ths. So that is the 1/10,000ths. Okay, so similar to this one, we just put a 1 there, an O there, to tell us that is the 1/10,000ths. So this value here is 10,000 times smaller than the ones. So the value for that 2 would then be 0.0002. Okay, so the next value, let's say if we had, say, a 5, this would be for the 100,000ths. So that's a capital H there for 100,000ths, and the value of that would be 0.00. So that's 4 zeros. 5. So that is 5 100,000ths. Okay. So the next number, let's say if we had a 1, so this will be for the 1 millionths. So OM therefore 1 millionths. So that would be 0. So we had 4 zeros here. So now we're getting 10 times smaller. So we'd have an extra 0. So 0, 0, 0, 0, 0, 1. So that is a 1 millionth. So let's label the rest of the values. So with that 4 there, so that is 4 1/10ths. That would be 0.4. That 8 there is a 100th. So that would be 0.08. So that is a 100th. So that is 8 100ths. And that 7 there is represents 1,000ths. So that is 7 1,000ths. So that is going to be 0.007.